In this exercise, we try to uh, convey the idea of how how large or how small the acceleration is on an electron or a proton. Often, an atomic uh, electrostatic forces acting on the electrons and protons inside an atom. They're so tiny, so uh, the field for the acceleration is different. This should be compared with the acceleration due to gravity, which is g is equal to 9.8 meters per second square. So let me make this large. When we are in a roller coaster, this could be about 5 times larger. That means 50 meters per second square. If we are in a when someone experiences an accident, this could be as high as 100 to 200 times g. So that's about 2000 meters per second square, and we die at such large accelerations. And in that scale, where we are talking about 1000 is too high, let's see what an electron or a proton feels like. So we are asking what is the magnitude and direction of an instantaneous acceleration of an electron when a total force of this is experienced. So the equation is mass times acceleration is equal to the force. So clearly acceleration is the force over the mass, and that's where uh, the size of these quantities comes in. The force is really tiny. Again, when we say force, we're comparing with forces due to gravity acting on ourselves. So that's what we experience. So this is I hat times a very tiny 2.0 into 10 raised to minus 19 newtons. And now we want to divide this by mass. And in this case, it's the mass of the electron. We're talking about the force acting on an electron, and an electron is really tiny. So it's 9.1 into 10 raised to minus 31 kgs. So force is really small, but then the mass is significantly smaller, minus 19 and minus 31. When we put this together, the direction of the acceleration is stays in the direction of the force itself. So that's still I hat. When we uh, do 2 divided by 9.1, that's 0.2197. I'll put this to two sig digits. And 19 and 31, that's 10 raised to like 11%, 12 units remaining. And Newton over kg is nothing but meters per second square. Let me rewrite this and then say how big or small this is. So that's 2.2 into 10 raised to 11 meters per second square. That's really large when we think about acceleration due to gravity. We said was 10 meters per second square, and we said if it is 1,000 times 1,000 meters per second square, then it's like having a car accident. But this is 10 raised to 11, significantly larger than that. But then this should be clarified that this is we're talking about an electron, and the experience an electron has, or the abstractness there is significantly different from the physical nature of we going and colliding with something. So that's a clarification that what kind of accelerations we can expect when we are having electrons and protons around. It is common to have until 10 raised to 14 or so in this scenario. That's a primary motivation for this exercise, acceleration. So what's the instantaneous acceleration? It is in the I hat direction, and the magnitude is about 10 raised to 11 meters per second square. That's all in this exercise. Let me stop sharing and stop